In the last class we studied up to the electrostatic potential energy, right? And its definition. What is a potential energy? Potential energy means the amount of the work done to bring a unit positive charge from infinity to the given point, right? Against to the electrostatic force of the field, that we call as the electrostatic potential energy. Then today let us talk about electrostatic potential. The electrostatic potential as so similar like a electrostatic potential energy. ಅಂದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಕೂಡ ಮತ್ತೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ಯಾಕಂತಂದ್ರ ಇದರ ಡೆಫಿನೇಷನ್ ಅನ್ನ ನೋಡಿದಾಗ ಇಲ್ಲಿನೂ ಕೂಡ ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಕನ್ಸಿಡರ್ P and Q are the 2 points. So when you want to bring a unit positive charge from the point R to the point P, some external work has to be done by the external force. That work done will be stored in the charge in the form of the energy, right? So that is why the electrostatic potential definition means, understand it properly, amount of the work done to bring a unit positive charge from infinity to a given point, against to the electrostatic force in the field. Is it clear? Yes, this is what we call electrostatic potential, and this is denoted by a letter V. Now in the chapter we are using means, what does it mean? Electrostatic potential. And remember, it is a scalar quantity. Notify the scalar quantity. What is the meaning of scalar quantity? The quantity which has only magnitude, no direction. Such a quantity we call as the scalar quantity, right? Then here the electrostatic potential is given by the formula W by Q. What is the meaning of this formula? Amount of the work done to bring a unit positive charge from infinity to the given point. So that we can represent by V is equal to W by Q. Is that clear? Yes. Then moving to the next point, the electrostatic potential difference between any two points can be represented like this. Because already we know that if I take Vp is the potential at the point P, VR is the potential at the point R, then the difference between these 2 point potential, it gives potential difference of the, so that between the points, right? Then this potential again can be expressed in terms of the work done, because already in the last class we know that W is equal to potential energy difference. So here UP minus UR upon Q, that can also be given for the potential difference. Then if I replace this by the work done from R to the point P with a unit positive charge, then potential difference will come. Delta V is equal to WRP upon Q. And remember, its SI unit is volt. What is the SI unit? The SI unit of electrostatic potential is volt, right? So then coming to the next point, that is the potential due to a point charge. Remember dear children, this is a very important question for the 5 marks. Every year, so or alternative years, you are going to get in the 5 marks question this. So what will be the question means, what is electrostatic potential, and derive an expression for the potential due to a point charge, right? So this is our derivation. Very simple and very short steps are given here. Then what is the consideration for this? Consider a positive charge which is kept at the origin. Consider a positive point charge plus Q that is kept at the origin. We want to find what is the potential at the point P. which is having the displacement vector or the direction vector r from the origin. Means ಇಷ್ಟರಪ್ಪ ಇದರ ಅರ್ಥ. ಸೊ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅದ ಕ್ಯೂ ಒರಿಜಿನ್ ದಾಗ ಇಟ್ಟಿವಿ, ಇದರಿಂದ ಈ ಪಾಯಿಂಟ್ ಪಿ ಅದ ಎಷ್ಟು ವೆಕ್ಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ಹೋಗದರಿ ಆರ್ ದಲ್ಲಿ ಐತಿ. ಹಾಗಿದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಪಿ ದಲ್ಲಿ ನಾವ್ ಈಗೇನ್ ಕಂಡು ಹಿಡ್ಲಿಕ್ಕತ್ತೀವ್ರಿ, ಪೊಟೆನ್ಶಿಯಲ್ ಎಷ್ಟೈತಿ ಅನ್ನೋದು ನಮ್ಮ ಏಮ್ ಅದ. ದಟ್ ಈಸ್ ದ ಡೆರಿವೇಶನ್, ರೈಟ್? ದೆನ್ ವಿ ನೋ ದಟ್ in the path means from the point P we can take the radial distance. So let us take P dash is the intermediate point in the path of the charge, intermediate point, and which is at a distance r dash from the origin. P dash ಅನ್ನೋದು ಒಂದು intermediate point ಅದ. ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ರೀ? r dash. ಎಲ್ಲಿಂದ? O ದಿಂದ, that is origin ದಿಂದ, right? And for this consideration, I used the condition that for Q is greater than 0, that means positive. We have taken here the Q is a positive charge. If Q is greater than 0, then remember the amount of small work done should be positive, right? Then by the Coulomb's law, see now the charge at the point P dash is a unit positive charge. Why I have taken plus 1 here? Unit andra 1 ada. So that is plus 1 coulomb charge is kept at the point P dash. Now I want to bring that plus 1 coulomb charge from the point P dash to the point P. Then it is clear that when you want to bring that from to the point P, the amount of the work done will be stored in the form of the potential energy, right? So we are going to derive now the derivation. By Coulomb's law, we know that the force, which force? Electrostatic force between any 2 point charges is given as 1 upon 4 pi epsilon naught q1 q2 upon r square. ಇದು ನಮ್ಮ ಕೂಲಮ್ಸ್ ಲಾದ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಐತಿ. ಹಾಗಿದ್ರೆ ಇದೇ ಫಾರ್ಮುಲಾನ್ನ ನಾವೀಗ ಏನ್ ಮಾಡೋಣ, ಚಾರ್ಜ್ ಕ್ಯೂ ಮತ್ತೆ ಇಲ್ಲಿರುವಂತ ಪ್ಲಸ್ 1 ಗೆ ಅಪ್ಲೈ ಮಾಡೋಣ, ರೈಟ್? ನೋಡ್ರಿ, this is the first charge and this is the second charge and distance between them is the r dash, right? Then electrostatic force on a unit positive charge at P dash is given as Fe is equal to Q1 means Q and it is a 1 and this is 4 pi epsilon naught r dash square into r dash cap. What that r dash cap here? It is representing the unit vector. Is that clear? Yes, this is the electrostatic force on a unit positive charge at the point P dash. Now, work done against this force. See, between these 2 point charge, there is an electrostatic force. Now, I am bringing the charge from P dash to the point P. Work is done against to that force. So the work done W, that is delta W, is given as the force Fe and the small distance delta r dash. That is equal to Fe means already we have here, substitute here, right? And this is a negative because work is done against the, so that force. So here delta r dash. So this is a what? The small work done. But our aim is to find what is the total work done to bring a point charge from P dash to the point P. Therefore, total work done by external. So, total work done by external force is given by W is equal to integration from infinity to the point R. And that is Fe means given formula dr dash. Then this is equal to, when you apply the integration of on 1 by r square means already you know that integration of 1 by r square into dr value will come 1 by r. So here after the integration our formula is q upon 4 pi epsilon naught r dash of the limits infinity to the point r. And when you substitute upper limit and lower limit here, 1 upon infinity will become 0. That's why upper limit means 1 by r only. So work done W is equal to Q upon 4 pi epsilon naught r. So by the definition, the amount of work done to bring a unit positive charge from infinity to the given point against the electrostatic force in the field is called the electrostatic potential. Therefore, W is replaced by V of R is equal to 1 by 4 pi epsilon naught Q by R. This is our important expression of the electrostatic potential due to a point charge. Hope you all understood, right? Then there is a small graph how the electric field and the electric potential changing with the distance r. Here is the graph, right? So along the y-axis you can take electric field or the electrostatic potential, and along the x the distance r. And you can see here the solid line shows us the variation of the potential with the r, that is the electric potential varies as 1 upon r, and similarly the electric field that varies as a 1 by r square, right? So this much enough today. Remaining we study in the next class. Thank you.